Joe, the managing director of a manufacturing company, calculates that he will need to spend €5,000 at the end of each of 4 years and €30,000 at the end of the 5th year to replace essential machinery. He engages an engineering company to carry out this work. It is now 1 year after the first €5,000 has been due, and it has not been paid. You, as head of the engineering company, are about to undertake the second €5,000 replacement, but have become concerned about the lack of payment. You approach Joe and he offers to pay you €3,000 now and €47,000 promptly in 2 years' time to complete the work. If the going rate of interest is 6% per annum per year, do you think you should accept the offer and give a reason? We will take the focal date, the comparison date, to be today, which is 1 year after the first payment was due. We then calculate the effective values of all payments received by Joe's suggested method and all payments made, i.e. billed according to the original agreement. So we're going to start off with the equivalent present values of the payments received. So we're basically going to start off with what Joe offers. So remember, he offers to pay €3,000 now and €47,000 promptly in 2 years' time to complete the work. And the rate of interest is always going to be 6%. So if we think about it, if this is now, 1 year ago was when the first €5,000 was due, and 2 years from now is when he's offering the €47,000. So 2 years from now is when he wants the work completed. So 2 years from now is the focal date, and we're working backwards to now. So since we're discounting backwards, we need to divide by 1 plus I to the power of t. So this is our formula. So P is equal to A divided by 1 plus I to the power of t. So we start off with the €3,000 now, and we're going to add that to the amount we get from this formula. So he's offering €47,000 in 2 years. So A is going to be the €47,000. The 1 plus I is going to be 1.06. We got 6% from here. The interest is 6%. And it's to the power of 2 years. And that ends up giving us €41,829.83. Adding that on to the 3,000 he's offering now gives a total of €44,829.83. So this is Joe's offer. He'll give us the €3,000 now and the €47,000 in 2 years' time. So this is what that actually works out as. So next we have to work out the costings of the machinery that we need to replace. So remember that €5,000 gets spent at the end of each of the 4 years, and €30,000 will get spent at the end of the 5th year, and this is to replace the essential machinery. So the I is still 6%, the interest rate. So the equivalent or present values of payments made, which is the billed cost of replacing the machinery. So if this is now, then 1 year ago, €5,000 was due. So we're going from 1 year ago forward to the present date, which is now. So we're growing forward. So we're going to use this formula where we multiply. So we have P is equal to A times 1 plus I to the power of t. The A is the €5,000. That's multiplied by 1.06 because remember the I is 6%. And the t, the time is 1. It's to the power of 1. So the €5,000 due 1 year ago is now worth €5,300. So we've gone forward. We've accumulated forward, or we've grown forward from 1 year ago to now. There's €5,000 due now to replace the next set of machinery. So that was told to us in the question, that €5,000 is due now. And now we have to look forward to the next 3 years. So there's €5,000 due in another year. So if this is now, and the next €5,000 due in 1 year, we're working backwards from +1 to now. We're going backwards from 1 year from now to the present date, which is now. So since we're discounting backwards, we're dividing by 1 plus I to the power t. So this is our formula. And we're doing that for the next 3 years. Because obviously in 1 year's time, in 2 years' time, in 3 years' time, that's all in the future. So we're working backwards to now. So for the next 3 parts, we're using this formula. So the A is going to be €5,000. 1 plus I is still going to be 1.06 because it's still 6% interest. And the T is going to be 1 year. So in 1 year's time, the €5,000 will be worth €4,716.98. The €5,000 in 2 years' time. So if this is now, and this is in 2 years' time, we're working backwards by 2. So again, we use this formula, and we have 5,000 divided by 1.06 to the power of 2. And that gives us €4,449.98. And in 3 years' time, we have to replace machinery worth €30,000. So if this is now, and this is 3 years' time, we're working backwards by 3 years to the present date. So again, we use this formula, but this time it's €30,000. It's still divided by 1.06 because the interest rate is not changed, and it's to the power of 3 years' time. And that gives us €25,188.58. So adding these all together, we get €44,655.54. So this is the total cost to replace the machinery from 1 year ago, the €5,000, now the €5,000, the €5,000 for the next couple of years, and then the €30,000 in 3 years. So the equivalent present values of payments received was €44,829.83. So this is basically what Joe offered us. Remember, he offered us €3,000 now and €47,000 in 2 years to complete the work. So that worked out to be €44,829.83. We then had to work out the cost of replacing all the machinery. So the equivalent or present values of payments made, billed cost of replacing machinery, we worked that out to be €44,655.54. So that was the replacement of all the machinery parts. Thus, the NPV, the net present value, is €44,829.83 minus €44,655.54, which leaves us with €174.29. Since this is positive, you should accept the offer. This is unless you don't trust Joe or believe his company will not be around in 2 years' time. So this is what Joe's offering. This is how much it costs you to replace all your machinery. And this is the balance.